Welcome everyone to our Q1 2025 Security Seminar. I'm Mamta Gupta, Senior Director Marketing at Lattice Semiconductor, and today we will be discussing the top security trends that have been emerging globally across our major industry events like CES, MWC, Embedded World, GTC, and TCG that just concluded in the first quarter of this year. Each of these shows offered a unique view into how the industry is evolving its approach to trust, zero trust architecture, post quantum cryptography, and cyber resilience needs. I am joined by two fantastic panelists from Lattice Semiconductor, Carl Waxwender and Eric Sivertson. Eric, Carl, great to have you here. Please take a moment to introduce yourself to our audience.
Hi, my name is Eric Sivertson. I'm Vice President of the Security Business here at Lattice. And just like Mamta said, between the three of us, we've spent a lot of time this past quarter in various conferences that affect kind of what we see the future will be with security. And we're looking forward to share that with you.
Yeah, Carl Waxwender, Senior Principal Architect from Lattice, focusing on the embedded side. And I will give you a little bit insights and trends on the embedded systems, IoT systems, and also robotics. And over back to Manta.
Thank you for the introductions, Eric and Carl. So dear audience, these industry shows, they aren't just about future tech. They give us a direct view into what's already happening in the industry, what's getting implemented, what's getting prioritized, and where customers and ecosystems are heading. We also recognize that not everyone gets to attend these events. So our goal today is to bring you the security relevant highlights, the real signals, and a sense of what's next, especially if you're building, deploying, or managing trusted systems. I'll structure the discussion today in 3 rounds. We will start, each of us will take turns giving you overall takeaways. Then we will go into some conference-specific deep dives because each of the conferences have their own focus areas, and then final reflections and the trends to watch. So Eric, I'll come to you first. What stood out to you this quarter in terms of security direction across all of these conferences?
Yeah, thanks, Mamta. So for me, I represent Lattice at the Trusted Computing Group, TCG. So we had our annual members meeting in February. Also do a lot, as you know, with you on the server side and what I would call big data. So I was at CES with you. And then, Carl, I do a lot with you over with the embedded side. So I was at Embedded World. So I'm going to give you kind of a synthesis of all of that. The first one is AI. This is the big elephant in the room. AI is huge. It is going faster than any new technology I've ever seen. It was all over all 3 of these conferences that I went to. And so I think the key takeaway is you've got 2 aspects of security with AI. There's AI applied to security, and then there's security applied to AI. And I think that's a critical topic that people are not catching yet, that there is a subtlety between the 2. And the big one on the security applied to AI is data provenance. And so that topic is now emerging everywhere where people are concerned about, hey, I asked ChatGPT or Grok to give me an answer. It gives it to me, but where did it get the data for that answer? Where did that model get its data to be trained? And so the concept of malicious data, data pool poisoning, malicious training, there's a whole bunch of security issues that are wrapped around that. And then the other side of the equation is using AI actually to find problems in security or to do attacks. So I see that trend growing very quickly. The other big trend I see is cyber resilience. Particularly in Europe, CRA is a big topic. That's the Cyber Resiliency Act. I know Carl's going to talk quite a bit on that topic. We see that growing, and that's going to be a critical entry point for a lot of folks. And then the last topic, and this was really big at TCG, and I think it's big on infrastructure, is post-quantum crypto. And I know, Mamta, you are going to spend a lot of time on that. That's one of your favorite topics, and look forward to your take. But that's what I see. So back to you, Mamta.
That's true. And I'm say across all these conferences, AI was the main theme that was guiding how these infrastructure or the consumer, the industrial, everything is now geared and run by AI or getting ready to be run by AI. And there comes the real pressure to prove that devices that are either running AI, as you said, or are being run by AI are secure by design. So expectation is not just encryption, it is also about identity of who's running what, about crypto agility, because now new cryptographic standards are coming, and their ability to resist attacks. So across these conferences, I saw three themes come up. That first of all, AI is expanding the attack surface. We were, prior to AI, we were securing almost static systems. We were securing a layer at a time. But now these systems are morphing, changing, they are automated. Hence, the attack surface is growing exponentially. And then zero trust has to be enforced. And when we say zero trust means prove your identity before you connect and prove that what you are running is the approved version of the firmware or software that you're running. And then, of course, PQC. It's moving so fast. Till last year, people were shaking their heads that this is a trend that our grandchildren will see, and suddenly it's burst into mainstream. And across the conferences, I saw so much energy around it and so much urgency around it. And we will cover, as we do the deep dive, into what it means for building your new cyber resilient systems or future proof systems. Carl, how about you?
Yes, on the embedded system, I think there's a little bit of different trend. This is not the AI topic on the security side. It's more AI for learning and for uncovering on data. And we see there are a lot of IoT systems in the field, and the numbers are going up, going up, going up. So you see it as in home or in your field area. And that's more or less the biggest challenge what the industrial guys have. So how they can protect more or less this tons of IoT systems in the communication. So in the past we had this OT world, this operation technology shielded from the whole IT world. Now we're coming into this world, we bring this together, and I think AI will play sooner or later a problem, a security risk there. But today we need to come to the first step to secure the communication, to make encryption back to back, to have more or less this secure updates for the tons of end devices enabled, to have root of trust in the systems, to have the unique ID from the IoT systems. So, and that falls more or less then into the secure lifetime. So in the embedded world, you know it, and Eric, you have seen it in this factories, what we went through. You have equipment that's 20 years old. How you can bring this old equipment up to the security level, what you need today, how you can align this CRA needs or the CRA standards to your brownfield. Nobody will reinstall all this old business. We have seen Windows XP devices running in factories, and how you can bring this more or less over the lifetime. And if they start now with a greenfield implementation, so it starts in the design to think about security, to make the implementation ready for PQC or for future AI topics, to enable tests and the maintenance. I think the maintenance is the tricky stuff to have a security lifetime over 15, 20 years in a field device. I think that's a big challenge, and what I have seen is a lot of customers are using TPMs. But it's TPMs will not live for the next 20 years. So what is the answer to this? And the customers have really a challenge on the lifetime side. And also the whole authorization of the access of the devices, on end-to-end encryption or data hacking from the sensors. Could you more or less manipulate a sensor data and give wrong data to the main system? Then the whole factory could collapse. All these topics are more or less now in the security corner. And what I have seen in the last and most embedded systems is use a protection system. But if you have protected your system with some software or some hardware, how you can more or less detect a risk, how you can go after a risk in real time. And if you have a risk, how you can go with a recovery phase into this to say, okay, my system could recover without any impact. And if you look a little bit deeper into the cyber resilience, you find this protection, but also you need to detect this risk, what you can get in this tons of devices, what you have in the field. And then you would like to have an automatic recovery phase to come back. So at the end, a PFR implementation, platform firmware resilient implementation, what we know from the server side. And I think that is more or less a question from the embedded world, how they can make the implementation. And we try to help them to make this with FPGAs. FPGAs aligns very well with the lifetimes and also with the challenges what they have today.
Oh, thank you, Carl, for that good introduction and a deep dive into embedded. That actually segues us into our second round, which is a deeper look into what each of the conferences were focusing on. Um, I attended CES, MWC, and GTC, and in CES again, it was all about agentic AI and AI coming to robotics and consumers and automotive, everything. And as Eric said, it's about data provenance. It's about AI models being signed, that you are running the models that you train. And I know Eric will cover more on the data provenance side. So on the MWC side, the telecom security trends, there were so many sessions and keynote tracks for secure emerging technologies, for a call to action to unite against ecosystem threats, where various operators showed how they're embedding zero trust, root of trust into 5G and open RAN systems. Attestation is becoming a requirement for between network functions, not just for access control. So, and then all the platforms are being hardened with the root of trust. So DUs, RUs, and I saw a proliferation of FPGAs acting as root of trust, and quite a few Lattice FPGAs being used as root of trust and for doing firmware resiliency. Now, when AI gets deployed in base station and gateways, it really makes edge a critical boundary. So we saw a big push for signed models, verified inference engines, secure provisioning for this edge AI. And then PQC was a big theme in MWC as well. Multiple operators showed their PQC protections in every layer of the RAN. We saw demonstrations like PQC enabled eSIM activation, firmware signing with hybrid crypto. So a lot of people are concerned that PQC models or the new algorithms may not stand the test of time and may evolve. So they're hedging their bets by doing classical crypto as well as dilithium signing. They were showcased. TLS with Kyber was showcased. So that's a very big access control or access hardened with PQC use case that we saw. So because operators are very worried about PQC algorithms being new and they might evolve, so there was a uniform cry for crypto agility and adopting PQC from the get-go and not retrofitting it. So whatever new things are being built, PQC will be adopted from the get-go. From a GTC perspective, the focus was about AI, compute, data center, And again, security was at the forefront. The focus was on orchestration security, on the motherboard level. Now we are talking platform root of trust, all the way from boot time to runtime enforcement of trust. And there were many sessions about secure provisioning, agent identity, and then generative AI requiring signed and validated models. There was a whole quantum day at GTC that emphasized how quantum computers are not a thing of 20, 30 years away, but they are coming in. And there was a rallying cry, demos next year. So that showed a growing um, recognition that quantum computers are coming, and they are going to threaten our current classical cryptography. So CNSA 2.0, ready firmware, TLS, and onboarding, they were all the themes that people had showcased. There were sessions where people had highlighted. There were multiple quantum technology companies that had showcased their technology there, how to secure various aspects of data centers. So, Eric, I would like to hear your thoughts about the conferences that you attended.
Yeah, sure, Mamta. And you and I were both at CES, and I think we had similar views. The AI, agentic AI, which is really where AI is going to get to human level intelligence and then get put in a humanoid, which is kind of a crazy concept for a lot of folks. 100 years ago, no one, it was science fiction, and now it's going to happen. The other part of AI that I thought was big from CES perspective is automatic driving. So I think that you're going to see more and more AI jump into tasks where humans will be put at risk, for lack of a better way to put it. And the whole idea of trust is actually a human term. Electronics, there was never a term trust for electronics. Trust is all about human interaction. And a fundamental for us as humans is identification. So being able to have clear identity on systems is going to be critical. Carl mentioned that earlier about unique IDs. And that is a foundational piece that not only will you need that at the composite or system level, we need it all the way down to the component level. To put a shameful plug in for Lattice, we have that in all of our root of trust products. And any product being built today, TPMs were a start of that process as well. So I think the AI story out of CES is that humans and AI are going to interact in ways that human life will be put in jeopardy. And so security and trust will be absolutely critical. And that means that you can have ways to know that the system is inherently trusted, and you know what system it is, and that the data and the models that it's using and generating are also trusted. So going over to TCG, the Trusted Computing Group, these are the guys that bring you the TPM. That organization is evolving to look at all of this. There are about 4 billion TPM devices out there right now. And like Carl said, for a lot of industrial, that's the foundation of security in industrial. Yet the majority of those devices don't have the capability to handle the full PQC algorithms, which is now going to be a big part of the future. And they were also originally designed more as a vault or an attestation vehicle. The concept of cyber resilience is new and was not embodied by TPMs in the beginning. So TCG is really starting to look at this evolution. We had an entire session on trusted computing future, emerging use cases and solutions. Data provenance was a big part of that discussion, as was how to deal with the AI issues, and also the evolution of post-quantum. We even had a whole session on MLDSA, which is the dilithium, which is the new signature algorithm for post-quantum. So it's clear that TCG, and they have a cyber resilience standard as well, that working group spent a lot of time on CRA. So the organization that brought you TPM is now starting to really look at how the world is changing and to evolve those standards. And then last was Embedded World, was there with Carl. and he and I saw quite a bit of interesting stuff. Again, CRA to me was a big topic. I've been going to embedded world for a long, long time. So has Carl. And the last too long, right, Carl?
Yes.
So we last year there was a few booths with the word CRA. This year I could go to many booths. Any booth that was going to have any security related product or critical product, they had a big tagline: Cyber Resilience Act or CRA over the top. So I think particularly in the industrial space in Europe, CRA is a bigger and bigger issue. I'll let Carl dig deeper on that. I think one of the foundations for it is IEC 62443, which I'll put one more shameless plug in, which is that, Lattice does have IEC 62443 compatible products. We've done a lot in that space. So not to steal too much of Carl's thunder. So I think from the embedded world perspective, it's the zero trust applied to, just like Carl said very well, OT, IT coming together. And then how do I be compliant with CRA because I need to defend and recover my system? And post-quantum, people know how to spell it. People know how to say the words. Last year, some of them didn't know what it was. So I think that's going to come in a little bit of a laggard stance, but it's on its way. So that's my take, Mamta.
Yeah. Thank you, Eric. No, that's very well summarized. Now, Carl, I will go back to you, and this is almost the start of our round three, where how FPGAs can help service these trends. You brought up a very good point that there are legacy systems in industrial that are 20 years old. How do you upgrade them? So take us through what the challenges are in your segment, which is industrial robotics, automotive. How are people solving these challenges, especially using FPGAs?
Yeah, Manta, I would like to jump 1 minute back to the embedded world, and this comes to your question then. So what we have seen, and Eric was with me on the show, we have not a spot solution. Some guys brings you a perfect ARM security solution or the RISC-V solution to protect something, or a secure flash device, or some innovation on the secure manufacturing side. But there is not really an end-to-end solution available. What we can see that you can use a root of trust, get more or less a root of trust in your system, get the system then aligned with the whole communication, bring this up to this industrial standards like OPC-UA, and bring this up to this IT world. And that is more or less bringing me to this industrial world, what you said in the brownfield. So the industrial customer would like to use secure protocols. OP3 is one of it. There's 2 or 3 others, and they would like to build a security island around the devices that can't more or less update with the security features. So there's more or less islands, protect this with gateways, make more or less a firewall around this and say, okay, that is more or less a critical infrastructure, and protect this as island. But the most customers are looking now into to upgrade the systems to have the unique ID, the unique fingerprint in the end devices, in the sensors, to say, okay, I can trust the data what I get for AI or whatever. Not only this, we have also the situation that we have what you said, robotics, humanoid robotics. These guys or these robots are 200, 300, 400 kilograms. I don't know how many pounds these are. Sorry for this. I'm a European. If they are staying and have a safety error or get a hack, what happens? Is this robot falling down on the next human or a dog or whatever? So I think the security and safety topic is playing more and more in this industrial environment together, and we need to look this from the system perspective. And what we made is more or less, our MachXL 3D devices, devices that have the root of trust in the FPGA. We aligned this with CPU vendors and build up a complete hardware security root of trust up to a protocol stack implementation and have their blueprint for customer to protect brownfield implementation, and use the same for the new robotic implementation for motor control, for AI control, security, and other topics. So this is more or less the trend what I'm seeing. The CRA is now impacting all these field devices that we have. First of all, this protection, that we have key management, orchestration, all the stuff enabled, but also to have monitoring on the side. So you need a monitoring on the Cyber Resilient Act. If you run in a risk or in an attack, then you need to have their recovery phase. And this recovery phase should not take hours, because that's availability. If you think your humanoid robot have a security or safety bug or whatever and falls down, and then you need 4 days to bring them up, and he's in front of your door, it is not really helpful. So, and you see the news, humanoid robots are running in BMW factories and producing cars, and they should run 24/7. And if you have one security risk, or a software update that goes a little bit wrong, or you have a hack on this side, you're not allowed to fall or to make a break from 2-3 hours. That's his money. Each car costs 50,000-60,000 euros. If you go to a car manufacturer every 2 to 3 minutes, you have a new car. If you miss 1 hour, you can make the math how many millions you are losing. So all the stuff are bringing this together, and I think we as team, Manta, Eric, and I, we have really developed a blueprint with our smallest security device that we can have the real-time protection in the FPGA, that we are monitoring all the software updates, all the interfaces, have the root of trust from the secure boot up, and have also the management for new or updates on the security topologies or encryption or whatever you would like to update in the FPGA. And with this, you have more or less a future-proof solution, I would say, for the next 10 to 15 years. And I haven't seen this on a CPU. I haven't seen this on a flash. So they have now a release that's ASIC, and I don't know what happens in 2 years, in 5 years, in 10 years. Is this really strong enough to go against the attack? A lot of industrial customers are aligning with our view that FPGA is a perfect fit to the security. And we have a lot of design work to do for the next years. And CRA is really a big impact, and also the IEC 62443. And that is also a trend, what we are seeing, that this next step on the security level is coming in. So we will see, I think, very soon, and I've spoken also with other companies, that PQC get more or less a place in the IEC 62443. And this is more or less then the next step that the customer needs, really post-quantum cyber resilient implementation to get more or less the CRA enabled for the next 20 years. So big breaks, big changes. I think security was not really the focus from the industrial guys the last 20 years. And now more and more people are looking into this because they get more and more challenges.
That is so true. And as I was walking the floor in MWC, every booth had security in their taglines. And actually, I found a very big booth which had no security in the tagline. So I went up to them and I said, "Hey, don't you worry about security? I don't see it anywhere in your taglines or slogans or your displays." And they go like, "Hey, security is in our DNA. Do you advertise your DNA?" No, it's a given. And that to me was music to my ears. Running security marketing here and trying to establish a vision for security solutions and trying to roll them out. That kind of acceptance of security with telecom operators is very illuminating and very welcome, because all our data goes through them and everything connects through 5G. So from my perspective, how FPGAs could service these trends. First of all, I would talk about continuous security. So I talked about AI now necessitating that our edge systems like base stations or industrial gateways, they need real-time security. They need real-time authentication. And if you put an FPGA as an anchor of trust right behind them or in them, then they can ensure that whatever gets run on them, whatever data gets collected or passes through, there is attestation, there is identity attached to that. It can be signed. There is a secure boot when these systems come up, and the signing keys are properly managed. If you're using hybrid crypto, then your classical keys and post quantum keys, they can get really large, and you've got to be able to manage them. So key management becomes a very important thing. And FPGAs in general can do it. They are flexible, programmable. And if you couple it with a good security root of trust implementation in the FPGA, like Lattice has in its root of trust products, then you can have FPGAs acting as anchors of trust. The other thing that is required is enforcing trust. Um, the models, the AI models that are being run must be verified, and your environment of running those models should be trusted. That means the firmware that you just loaded to run that thing should be attested that it's the right version, it's the right source, it's coming from the right source. And then customers, who can be sure of these models being trusted and have secured the environment, can provide service to their customers, which is with trust. As Eric said, trust is human. So we have to be able to trust systems that are being run by AI, and security will ensure that trust in the future automated system. So this, why do customers care? Why does anybody care about security? Well, in from my point of view, if you want to employ your AI models to run sensitive systems or to run systems that interact with humans, you better assure me that they are secure. So I think a lot of AI providers, model providers, and system providers are realizing that the only way they can, improve or evolve, uh, current classical systems through AI is to first foster trust through very secure implementations. And then I couldn't escape post quantum anywhere, and I didn't want to. It's welcome music to my ears, having led that strategy at Lattice for a while. The awareness about CNSA 2.0 standard, especially in MWC and GTC, was amazing. People realize that this USA standard will force them to be post quantum ready. People can talk about when quantum computers will come or not come, a decade or 2 decades, but US government has taken a stance that, look, you got to provide post quantum security to your data, and they are trying to protect against harvest now, decrypt later kind of attacks. So MLDSA signing or Kyber protected key exchanges, those are being demanded right now, especially from telecommunication and server customers. And by 2030, a lot of people don't realize that by 2030, every root of trust that will be deployed in US infrastructure, be it in industrial applications or automotive or consumer or any other niche applications, it has to be post quantum resilient. So the horizon is not very far away. It's just 5 years from where everybody will be has to be post quantum resilient. And for servers and telecom, it's now. And again, FPGAs provide that flexibility to drop in new algorithms to maintain life cycle compliance. As new algorithms come in, crypto agility is a big deal there. And Lattice has patent pending innovation where we can update PQC algorithms in the field. So all of these, trends and how we can service with our FPGAs, that was very encouraging to me. That industry is going in the right direction towards security. As a consumer and as a solution provider, both ways, I want to see more and more security in the ecosystem. And then we have the products to service those trends. And to me, that was the biggest takeaway. Eric, your take, and then I'll invite you to wrap it up.
Yeah, so Mumta, you said it very well, as well as Carl. If there's one thing I want to leave our audience with, is that the AI era, and that's what we're in, or the age of AI, however you want to look at it, I really believe will be fully enabled, the security and trust of it, by FPGAs. So if you look at the chaos and change, look at, as Mumta said, post-quantum is a new standard, and those standards could change some. If you look at the CRA, it's a new requirement. If you look at what's happening with TCG, with TPMs, and the entire change of that structure, we're in a huge chunk of change to make all of this technology work. And so foundationally, FPGAs fit very good when that happens because it's easy to do updates and we're very flexible as programmable hardware. So any algorithm, any thing that even AI can think of can be implemented much quicker on an FPGA than being forced into an ASIC. And we're not constrained by an instruction set like a microcontroller. So I really believe the age of AI will be empowered by FPGAs. If you go back in time, I ran a business unit for aerospace and defense with one of our competitors. And one of the niche plays that was very big for FPGAs for A&D was DSP. So you go back in time, you can see that for a long time, DSP was fully enabler by FPGAs. I believe the same is now going to happen with artificial intelligence, that the motor control in those robots is going to be probably done with FPGAs, but done securely and in a trustworthy way. The bring up of AI systems in the cloud will be done in a secure, cyber resilient way by FPGAs running post-quantum algorithms. And then the communication links to bring all of that together and dynamic changes to those algorithms, both for the distribution as well as the protection of that data, will be done by FPGAs. So I really think we are in an AI era that will be fully enabled with FPGA technology. And at Lattice, we have, I think, some fantastic root of trust technology that could be applied to bring that trust and security to it, just like we were talking, all have been talking about. And so that's where I'd love to leave the audience and encourage them to call us, reach out if you have any questions. We're all available to you here, as well as the rest of the Lattice team. And we think we can help you not just survive, but thrive in an AI era.
Thank you, Eric. Great wrap up. Carl, any final words?
No, I think Eric said as well. So we need security in all our endpoint devices. I think that's a must-have. And as he said, we are ready to help you.
Yeah. Thank you. And thank you, panelists. Thanks for everyone for tuning in. We hope this gave you a valuable insight into the trends shaping security across telecom, data center, and embedded systems. And to learn more about Lattice's security solutions, please visit our website, www.latticesemi.com. See you next quarter. Thank you.